So far, we have finished to explain every piece of code of this model. It seems quite easy. Every line of code has a purpose, has its own logic, and it flows very well. However, it doesn't mean a NetLogo modeler's job is easy. Why it is not easy? Because the entire workflow is actually quite magical. Imagine you just begin to build this ant model. All you have is this one paragraph consists of three sentences. The first sentence says the ants, when the ants find a piece of food, it will carry the food back to the nest and dropping chemicals along the way. First sentence. Second sentence, other ants will sniff the chemical and then they can trace the chemical towards the food. Third sentence is that more ants will carry food back to the nest. They will reinforce the chemical trail. That's all we get about the model. And as a modeler, you will build the model based on only these three sentences. How can we do that? From three sentences, you are going to write all this code. You are going to build everything. And then you will work as expected and perform the whole thing, the whole dynamic of ant colony like this just from three sentences. I think this is amazing. It's actually very challenging. So let's just try to demythify this process. How to do it from three sentences into the whole modeling. So basically, although we get the problem which is defined by these three sentences, but actually we only need to write two parts of the code of the model, or we just need to write two functions. The first function is called setup. The second function is called goal. That's all we need to write. The remaining tiny functions is just breaking down the other code into small chunks so that we can reuse those functions. So if we look at a macro level, we just need to write two things. We just need to write two functions. The first one is setup. And the key idea of a setup is very simple, which is to build the world for ants. And the actual real thing we need to write about the setup is this function. To set up patches, we need to prepare the patches for three things. First, we need to build nest, and then we build food, and then we will color the patches, which are neither food area nor nest area. So we paint everything. We paint the nest, we paint the food. That's it. That's the setup. And after setup, we will do the goal procedure. Goal procedure is to build individual ants' behavior rules and ask the ants to interact as a whole. So that's the goal. So to do that, we have to create turtles. We have to create ants. So we create ants, and then for every ant, it will move according to three rules, like looking for food, and when you find food, you will carry food back home, and while you were carrying food back home, you will drop some pheromone. That's it. Okay, that's how we move, how the turtle move. And then while the turtle is moving, we should change the turtle's color to specify what state the ant is in. It is in the looking around state, it is in the carrying food state. We can use recolor to color it. But besides the ant behavior, we have another very important factor, that is pheromone. Because all we have been doing so far is create the world and create every ant simple behavior rules. Those rules are applied to every single ant, so they're the same. However, ants do not acting independently. They actually are interdependent with each other. And how do they do that? Where does interdependence come from? That is made possible by pheromone. Because one ant's pheromone will affect the other ant's behavior. So we need to define pheromone. And the pheromone has two basic property which every chemical have. That is diffusion and evaporation. Every kind of chemicals, they should be able to diffuse themselves by certain rates, which is to diffuse its own chemical or level of substance to the surrounding area. And the second property is that the pheromone will evaporate, will disappear eventually. It also has a rate for that. So that's how we define pheromone. And then once we define pheromone, we still can do some painting. That is, the pheromone is decreasing, so the color of the patches should somehow vary its color brightness as well. So we use recolor patches to show that. And that's all we need to do for goal. And the remaining parts you just set up for some automation, like when to stop. And the remaining functions just breaking down the main functions into smaller ones so that everything can be organized better. So that's it. From 3 sentences into a whole model. It's not that crazy. It is manageable. It is possible for us to achieve it.